Everyone, today I want to go over MPLS shortcuts for IBGP sessions as well as IGP shortcuts. So a couple key points here. MPLS shortcuts will minimize the IBGP sessions, so you won't require to have a full mesh of IBGP sessions in your core. You only need to configure the tunnels on the eBGP session routers. So whatever your external facing routers are, you just need a session on those two, if it's just a point-to-point. Transit routers must have MPLS label swapping support. So RSVP, LDP. RSVP signal has the highest priority over LDP tunnels. You can test this, set up an LDP tunnel or an RSVP. It will always choose an RSVP tunnel over LDP. And the lower metric is always preferred in regards to the tunnel. So again, LDP or RSVP, traffic engineering, LSPs have to be configured on the transit routers in order to forward all the traffic. And BGP must be configured to use MPLS shortcuts, again, on the external facing routers with the eBGP sessions. So those are a couple must-haves, and also there are IGP shortcuts. The IGP shortcuts will forward with native IP traffic and IP signaling. So this can be done again using LDP or RSVP traffic engineering tunnels. So the RSVP shortcut command will be installed inside your OSPF or your ISIS configuration. And the LSP to the final far end destination will be replaced as the next hop in the IP destination. So that's the way it knows how to get to the next hop. It will signal to the LSP. And a couple of things with your MPLS LSP configuration: it cannot be a loose path. You either have to set hop by hop explicit configuration of your path, or you can simply enable CSPF and traffic engineering. So here's a little export of how things should look when you look at your route table. You should see the tunneled RSVP, and this is your next hop, and this is how it's getting there. So everything will kind of look the same, but you should see this output next to your next hop destination. So go ahead and show you guys what I have going on here. Here are my routers 5, router 6. I have loopbacks. Here are the loopbacks, and these are eBGP sessions between 6 and 2, between 5 and 1. What we're going to do is we are going to cut this connection between 1 and 2, and essentially router 1 is going to use MPLS to signal the traffic and take a shortcut over to router 2 and forward the traffic across the core. So if this were to be a cut in your connection, your BGP session will continue to be up due to the MPLS shortcuts and therefore forward the traffic. Alright, let's take a look. So here's the route table. Here's the loopback address. So I am exporting loop 1 into BGP, sending it over to router 1. And as you can see, I can ping across. So there it is. It's reachable across the network from router 5, 1, 2, and then final destination router 6. But that is using a normal IBGP session in the core. And so let's take a look at my route table over here. So you can see that everything looks good. I'm getting my routes, I'm sending them over to my IBGP neighbor, and those are exporting. And you can see there's different ASs. So 65-200s over here, 65-300s over here, and then 6500 is my IBGP. So what we're going to do is enable MPLS shortcuts. So say router 1 to router 2 this connection goes away. So I'll just do this the easy way here. So we'll shut this down as well as the other side. Shut. So now this ping will not go across from router 5 to router 6. It has no way to get to it. Once router 5 signals over to router 1, the traffic has no idea how to get over to router 2. So what we're going to do is enable MPLS shortcuts. So we'll go over to our router 1. So here's the simple configuration. eBGP session to router 5, and then my iBGP session. Make sure your next hop self is in there. So we're going to configure the tunnel. Next hop resolution, shortcut tunnel, family IPv4. And here is a couple things I want to bring up. Just to prove that it is going to be an MPLS tunnel, we'll disallow the IGP and we'll say resolution any. And just keep in mind you can set resolution to RSVP with the filter. Or there's other options. You can do segment routing using OSPF or ISIS or just LDP. So there is my tunnel configuration. I'm just going to say resolution any. It will default to RSVP since that is the higher priority. We'll do it on the other side here. Resolution any, and we'll disallow IGP. Okay. So there's the configuration. Next hop resolution, we'll shortcut tunnel using IPv4 family. No IGP, resolution any will resolve to using RSVP tunnels. So now let's look at our route table. Okay, so we're seeing both. And there's my tunnel. So router 2 is, so you are seeing 5.5 loop back from router 5 over to router 2 via 1 using MPLS shortcuts to get to router 2, which I'm assuming is probably going router 7, router 2, because this is the best LSP to take there. It wouldn't go all the way around. So let's see if our ping works now. Okay, so we can get to it. 55, I'm sorry, 66.6 source, 92, 168, 55.5. Just leave that going here. So there's our, so now we'll look at the fib table here. So there is transport RSVP using LSP1. And here is the trace route from router 5 to router 6. Its loopback address goes to 151. This is an MPLS node, and then it reaches the interface of router 2. And then the final destination, which is router 6. Router 6 loopback's address to reach its destination. So now what I want to do is show you how to use IGP shortcuts, which is pretty easy as well. So here's the tunnel table. So this command's pretty cool. You keep an eye on what's going on. So let's go ahead and take off the shortcut, MPLS shortcuts. So this is a little funky way to do this. I'm not sure why it's done this way, but if you want to get rid of your MPLS shortcuts, you got to go into next hop resolution, shortcut tunnel, family IPv4, resolution disabled, and you make sure you clear your family IPv4, disallow IGP. no disallow IGP, and now everything's gone. So that's how you clear the configuration. You can't simply negate the top level command and clear everything. You got to drill all the way into it and say disabled. So we'll do the same here, same thing here. So I'm allowing IGP shortcuts by negating this command now. And that's exactly what we want, because that's what we're going to do next, is use IGP shortcuts. And again, just to touch on what I said earlier, if you're going to do IGP shortcuts, you have to have traffic engineering enabled, and you have to have a static hop in your path, a complete static hop path, or you must use traffic engineering with CSPF enabled on the LSP. So just to prove what we're doing, so my configuration already has that, so we're going to router 2, CSPF is allowed, which will take in consideration traffic engineering traffic. So let's go into our route table. So let's just make sure this is broken over here. We can't get to it because again, no IBGP path is enabled here. So now we're going to use IGP shortcuts. As you can see, there's no more tunnels, so we'll go. I'm using OSPF in this case. We'll go into OSPF. You must enable traffic engineering, which I already have done, but the final command is RSVP shortcut. It's that easy. So router 2, RSVP shortcuts. There's my fib. And as you can see, now we have a bunch of tunnels, not just for BGP, but we got some OSPF tunnels as well, obviously, because that's what we're using. So if we go back to router 5 on this screen here, and we attempt to ping from router 5 to router 6, again, remember, these are 2 different ASs, so let's try it. So it's working, that's great. Now let's do a trace route and see what the difference is here, if any. There's my table, and this is the router 2. This is what we're looking at here, which again, same thing, kind of the same path. MPLS node in the middle, then which is router 7. If it was going the long way around, you would see the next hops, but they would be, MPLS nodes without the IP showing. So there you have it. That's how easy it is to set up an RSVP shortcut tunnel using either for IGP or MPLS. Thank you.